In this video, you are going to learn how to build a smart alarm system with Arduino. Whenever someone gets close to the sensor, the system is triggered and sends an email notification. To build this project, you need Arduino Uno input-output expansion shield, ultrasonic sensor, red LED, blue LED, I2C LCD module, Wi-Fi IoT module, and a few jumper wires. Start by attaching the input-output expansion shield to your Arduino board. Then connect the red LED to digital port 2 and the blue LED to digital port 3. Also connect the Wi-Fi IoT module this way, DT to digital port 4 and CR to digital port 5. Next, connect the ultrasonic sensor trig to digital pin 8 and echo to digital pin 9. Finally, connect the I2C LCD module SCL to A5 and SGA to A4. If you need additional help wiring the components, you can follow the diagram currently appearing on your screen. Also, don't forget to set the Wi-Fi module to wired mode. Before we move on, I would like to quickly thank today's sponsor, Jeff Robo. In case you don't know them yet, Jeff Robo is one of the leading global providers of open source hardware for students, makers, and engineers. For this project, they kindly provided the Mind Plus Arduino coding kit. This kit includes a set of components carefully designed for beginners, make it easier to take the first steps into the Arduino ecosystem. I highly recommend getting a kit like this to enhance your learning experience. I've put a link to Jeff Robo stores in the description below. Thanks again to Jeff Robo for supporting this video. Now let's get back to the build. To make our system work, we need to configure the Arduino to send data to the cloud every time the alarm is triggered. This data will eventually activate a script that sends an email notification informing you that the alarm was triggered. To help us accomplish that, we are going to use ThinkSpeak, since it's an easy-to-use platform that offers lots of useful features for free users. So go ahead, create a ThinkSpeak account and log in. The first step is to create a channel. Channels are used to receive data and display it on dashboards. We won't use the dashboard feature in this project, but I still recommend exploring it in future applications. Go to Channels, then My Channels, and click on New Channel. Give it a name like Smart Alarm and create a field called Triggered. Then scroll down and click Save Channel. Now that we have somewhere to send the data, we need a script that analyzes the incoming data and sends the email. To do this, click on Apps, MATLAB Analysis, and then New. Under Templates, select Get data from a private channel and press Create. You'll notice a new page containing MATLAB code. We won't need this code, so you can delete it. The code we actually need is available in the GitHub repository for this project. The link is in the description below. Open it, copy the code from the file called Smart Alarm MATLAB, pass it into the appropriate section and save it. You'll notice that there are 3 variables at the beginning that you need to modify with your own values: channel ID, alert API key, and read API key. To get the channel ID, open the channel we created earlier. At the very top of the page, you'll see your channel ID. To find the read API key, open the API keys tab and copy the corresponding read API key. Finally, to find your alerts API key, which allows you to send notifications, click on your profile picture in the top right corner and select My Profile. At the bottom of the page, you will find the alerts API key. Once you have these 3 values, pass them into the MATLAB code. Before turning on your board, we still need to configure one last setting. Unfortunately, the free ThinkSpeak account doesn't allow the MATLAB code to run continuously while monitoring the channel. So, to know when the alarm is triggered, we need to create a rule that periodically runs the script. The script will scan for updates and notify the user if the alarm was triggered. The shortest interval available is 5 minutes. That means even the alarm is triggered right now, the user won't receive the email immediately. As I mentioned before, this limitation exists because we are using a free account. But if you want real-time monitoring for your own application, you can consider subscribe to ThinkSpeak and explore everything the platform has to offer. That said, go to apps and then time control. Click on new time control. Give it a name like Smart Alarm Time Control. Then select recording, minute and 5 minutes. Under action, select MATLAB analysis, and under code to execute, select the MATLAB analysis tool you just created. Finally, click save time control. That's it. We finally configured all the cloud services we need. Now go back to the GitHub repository and copy the code from Smart Alarm System. This is the sketch you upload to your Arduino. Paste it into your Arduino IDE. Before clicking upload, make sure you installed the GFRobot RGB LCD 1602 library. Also, replace the values of the variables SSID, password, and API key with your RFI credentials and your ThinkSpeak write API key. You can find it on the same page where you found the read API key. After that, upload the code to your board and watch it work. When you turn on the system, it first initializes the Wi-Fi module and attempts to connect to the internet. After that, the system resumes monitoring. If you get close enough to the sensor, the alarm is triggered. The LCD displays a warning message and the LEDs blink alternately. The Arduino also sends data to ThinkSpeak. After a few minutes, if you check the email you used to create your ThinkSpeak account, you'll notice a message saying that the alarm has been triggered. Really cool, right? But how exactly does the Arduino communicate with the cloud? Well, let's take a look at the Arduino sketch. Here's the code running on the Arduino board. First, it defines some variables and objects, such as the Wi-Fi credentials. During the setup function, we initialize communication with the serial monitor, LCD, and Wi-Fi module. The program waits until the board is successfully connected to the internet. Inside the loop function is where the main logic runs. While the board reads data from the ultrasonic sensor, it also keeps track of time internally. When 1 minute passes and the alarm has been triggered, the Arduino sends the value 0 to the cloud. Then the process resets and starts again. However, if somebody enters the detection zone, meaning they get 10 centimeters or closer to the ultrasonic sensor, the alarm is triggered and the board sends the value 1 to the cloud. So 1 means triggered and 0 means not triggered. Inside ThinkSpeak, if you take a closer look at the MATLAB code, you'll notice that when it runs, it analyzes all the data uploaded to the channel during the last 5 minutes. Remember, this script only runs every 5 minutes. If the system finds the value 1 within that bunch of data, it means the alarm was triggered, so it sends an email notifying the user about the event. On the other hand, if it doesn't find the value 1, the alarm wasn't triggered, so there is no need to send an email. This verification step is crucial to avoid sending more emails than necessary. Also, ThinkSpeak has an anti-spam filter, and trying to send several emails within a short period of time can activate it, so be careful about that. And if you have any questions about how to properly use the components we exploit today, you can check out the tutorials on my channel. I have dedicated videos covering topics like how to use the Wi-Fi module, how the ultrasonic sensor works, and many other interesting tutorials. If this is your first time on my channel, you should know that this video is the final episode of a 24-part series called Arduino for Beginners. Throughout this series, we covered many of the topics a beginner should know to take their first steps into the Arduino ecosystem. We started with videos like why you should learn Arduino and simple topics such as how to use a breadboard. Then we moved on to more advanced subjects like Arduino programming and Introduction to Internet of Things. You watch all the videos, congratulations, you are a very dedicated person and I truly appreciate your support. Let me know in the comments below what you thought about this series. This course took almost 1 year to complete and I truly appreciate all the support I received along the way. I hope you enjoyed learning as much as I enjoyed teaching. Additionally, I'd like to ask you to subscribe to the channel since I plan on bringing more interesting content in the future such as ESP32 lessons, projects, and even videos sharing my journey of building hardware products and bringing them to the market. Also, if you want a more personalized experience, I offer one-on-one consulting. So if you are stuck in a project, need technical help, or you think I can assist you, you can book a call with me using the link in the description below. Before leaving, I'll also recommend watching the video currently appearing on your screen. I'm sure it will help you improve your maker skills even more. Thanks a lot for watching to the end, and I'll see you in the next one.